Hello everyone, welcome in the session number 3. This is the first session where we'll start the numericals on the double integral. So we'll see the examples on the type 1. So what is the type 1 examples of double integral? So type 1 is nothing but if the limits of double integral are given. So you'll observe here is one example where we are given a double integral from 0 to 2, 0 to 1, x square, y square, dx, dy. So this is a double integral we have to evaluate. Now, the first question may come in your mind that how to evaluate double integral. There is very simple process. To evaluate the double integral, we do the integration one by one. First, we evaluate the inner integral. What is the inner integral here? If you focus on the inner integral, this inner integral is up to dx. So just we integrate with x first and then outer integral is with y there. So whenever we evaluate the inner integral with x, we have to treat the other variable. Now in this case, the other variable is y that we have to treat like a constant. So if y is a constant, this y square is also like a constant. Okay. And whenever any example of double integral is in front of you, always you should correlate with the list of a prerequisite formulae. You will observe whenever y square is a constant, we have to integrate x square. We have to integrate x square with a, obviously x here. So to integrate x square, which formula will be here, which fits there? So obviously this formula number 2. So we have to use the integral of x raised to n formula in this example. So in this example can be completely solved by only this one formula, integral of x raised to n. So let me move here. Let me see how to do this integration. So to start the integration here, we focus on the inner. We integrate it with x, treating y like a constant. So the given integral I will become integral 0 to 2 outside as it is. As I told, y square is a constant as it is. Integral of x square is a x cube by 3. X cube by 3. Limits are 0 to 1 and dy is left as it is. So when we put here upper limit and lower limit, we get integral 0 to 2 y square as it is. We put here upper limit as 1 by 3 minus lower limit. When we replace x by 0 is a 0. So upper limit minus lower limit, this is the way we substitute the limit. And now this 1 by 3 is a constant outside the integral, and integral of y square is also y cube by 3 similar to the x square, and limits are 0 to 2. So in this case 1 by 3 as it is, 2 cube. 2 cube is 8, 8 by 3, and lower limit y replaced by 0, it's a 0. So the final answer is 8 by 9, and that is the end of the question. This is the end of a question. So this is the way we evaluate the double integral. If you observe here, mainly we focused on this inner integral first with respect to x. We integrated with x here. After that we integrated with y and we got the answer as 8 by 9. So very simple way, but most important thing, when we integrate with x, we treated y like a constant. Okay, so constant into x, constant into x square, that way. So the answer is 8 by 9 that we already seen here. So that about the first example. We'll move to the second question now. Second example. Here is the example 2. And now the important difference in the previous and this example is the inner limits. Inner limits are variable now. The main important thing that you should remember, the order of integration. The order of integration is not decided by this given part. The order of integration is decided by these limits. Whenever the inner limits are, say, f1x to f2x, means they are function of x, then the order is a dy dx. Order is a dy dx. Outer limits are always constant, say a to b. So integral a to b f1x to f2x, whenever the limits are in terms of variable x, the order should be dy dx. Okay, and the reverse one, if the inner limits are function of y, say f1y to f2y. So if the inner limits are a function of y, then the order is a dx dy. So outer limits are always a constant, say c to d. And the third case is there, where whenever the limits are constant, like a previous example, a to b and c to d. Remember, in this case, the order is whatever given that you have to follow. When all the limits are constant, the given order you have to follow. If it is given dx dy, follow it. Okay, so you will understand about the limit in the type 2 mainly, why the limits are, outer limits are always constant and inner limits can be a variable. All that things you will understand in the type 2. What is the main thing you should observe here? The inner limits involve the variable x. Here the upper limit is x, so that indicates this limit should be of y. So we should write the given integral first in the correct form. The integral I is a double integral 0 to 1, 1 to x, y, e raised to x, dy dx. The integral is a dy dx. So the correct order of the double integral is a dy dx. Once you decide the order, or once we get the order here from the limits, remember, just observe the integrand. When we integrate with y, we'll assume e raised to x like a constant. So which formula of integration we require for y dy? So obviously the formula 2. Okay, so integral y dy will take y square by 2 by the formula 2. Not only that, later on we require integral of e raised to x, e raised to x dx. To integrate e raised to x dx, we require the formula number 1. That is, the integral e raised to x is e raised to x only. So in the example 2, we require formula 1 and the formula 2 one by one there. So we'll start here the integration. So in this case, we have 0 to 1 as it is. We are integrating with y, so y square by 2, y square by 2, 1 to x, 1 to x, e raised to x dx as it is. Now we are going to replace this 1 by 2 is a constant. I will take it outside. Integral 0 to 1, and we left with upper limit. When we replace y by x, it becomes x square. Lower limit when y by 1 is minus 1. So x square minus 1 into e raised to x dx. Now at the beginning I told we require formula 1, but that is not correct now. Yes, you will observe we not come across the integral of e raised to x only. It is come across integration of x square minus 1 into e raised to x. So it is a multiplication of the two terms. So it is an integration. Yes, anyone? Which formula? The formula number 4. The formula 4 is the correct one. So we are going to use integration by parts. We'll take first as a u, algebraic function as a u, exponential as a v. So this is the example where we use integration by part. Remember, algebraic into e raised to x. All the terms are linear. So by parts. Integrating by parts now. So this 1 by 2 is a constant as it is. In by parts, we take first function x square minus 1. That is a u into integral of second. So integral of e raised to x is e raised to x. Yes, indirectly we use the first one. Minus integration of derivative of first. Derivative of x square minus 1. That is a 2x. And integral of second e raised to x dx. So this is the integral that we done. But still the integral is not completed, because here again we have to apply. Again we should apply the by part. This one is a u and this one is a v. So again integrating by parts. One more integration by parts we have to apply. So it is 1 by 2 x square minus 1 u into v minus. Now we are going to apply the by parts here. So I will take small bracket again, here round bracket. So u is a 2x into integral of second minus integration of derivative of first. Derivative of 2x is 2 and integral of e raised to x is e raised to x. This round bracket completed, square bracket completed, limits are 0 to 1. Okay, so this is the still the calculation is not done, so we have to just put upper and lower limit here. So we'll put upper and lower limit here, so that will give us the answer then. So the next step I will do it here. So this 1 by 2 as it is, 1 by 2 as it is, and let me do the complete integration first. X square minus 1 e raised to x as it is. This first term I written as it is. This minus 2x e raised to x, minus 2x e raised to x. And what about this last term? This minus sign, and here is again minus. Minus of minus is a plus 2 e raised to x, and limits 0 to 1. Now the last step, we put upper limit and the lower limit. Now see here, when we put upper limit, We replace x by 1. So 1 square is 1 minus 1 is a 0. So this term is 0. When we replace x by 1, so it is a minus 2 e raised to 1. E raised to 1 is e only. So minus 2e plus 2e plus 2e. So that is about upper limit minus minus. Now we are going to replace the lower limit. When we replace x by 0, this is a 0, but here is a minus 1 and e raised to 0 is 1. So this minus 1 will be there. This is a lower limit minus 1. Here when we replace x by 0, this term is a 0, but e raised to 0 is 1, so plus 2 is also there. So this second bracket, whatever this second bracket I written, this is a lower limit. This upper limit is lower limit. In upper limit, this minus 2e and plus 2e got cancelled, and you will get 1 by 2. This is a minus 1 plus 2 is 1, but outside there is a, so it is a minus 1. So the final answer is a minus 1 by 2. So minus 1 by 2 is the value of integral. That's one. That about the example 2. And the answer is a minus half. Minus half is the answer. You will see here. Okay. So this is the example 2 of double integral of a type 1. We'll move to the next question now. The example 3 then. So come to the third example. The question is double integral. Now you'll focus on the limit. Inner limits are given in the function of y. So the variable y is appear in the inner limits. So the order should be dx dy. So we should integrate with x. So x should have the limit in terms of y. So that is the way you should remember. So obviously we can have same order there. So the integral I will become, this integral I will become. Now there is no integrand. No integrand means 1 dx dy. We have to integrate 1 with respect to x. So obviously integral of dx is x. Integral of dx is x. Limits are 0 to root of a square minus y square, and that is a dy then. So that about the inner integral, one of the simplest integral that we have. So when we put limits now, it goes root of a square minus y square. Now lower limit, when we replace x by 0, it is 0 only, so it's a dy. So indirectly we have to evaluate the integral 0 to a square root of a square minus y square. Now which formula? Just focus on the list of the formulae. I told at the beginning only one of the most important formula is this formula number 10, where this formula generally we require to integrate the double integral over the circular region. So this is actually the whatever the limits are, the limits of the double integral are there. So that represents a quadrant of a circle of radius a. Hence, and double integral dx dy represents the area. So actually our aim is to get the area of the quadrant of a circle, and the answer will come pi a square by 4. Okay, so this is the formula we require here, because mainly you should correlate this formula. The formula is in terms of x, and we have to write down in terms of y only. So the integration is y by 2 root of a square minus y square plus a square by 2 plus a square by 2 sine inverse of y by a. That's one. And the limits 0 to a. So the last step comes here. So we replace upper limit. So when we replace y by a, see a square minus a square is a 0. This term is a 0 because y is replaced by a. This is 0. Plus a square by 2. When we replace y by a upon a is 1. So we get sine inverse 1. Sine inverse 1. So that about upper limit minus lower limit now. For lower limit, when you replace y by 0, this term is again 0. But this term is a minus a square by 2 sine inverse of 0. Sine inverse of 0. Now remember the sine inverse 0. What is the sine inverse 1 plus? You can use a calculator also. Sine inverse 1, calculator give you 90 degree. So that is a pi by 2. Pi by 2. And sine inverse 0 is a 0. So that is a 0. So pi a square by 4. Pi a square by 4. So this is the formula that we use, formula number 10. Not only that, we use two values. Sine inverse of 1. Sine inverse of 1 is a pi by 2. Sine inverse of 0 is a 0. So that two values we required. That's one. That about the example 3, one of the simplest example, but yes, repeated in the examination. It is asked pi square by 4. Pi square by 4 is the answer. Example 4. Okay, come to the example 4. So by observing the integrand, yes, you can guess which formulas we require here. Obviously, x into y into dx dy is there. So obviously, this formula number 2, most probably only formula 2 is enough only to solve this example, integral of x raised to n. Okay, so that is the formula we require. So we'll evaluate it now. So it is very simple example again. The limits are in terms of x. So what is the order? The order is a dy dx. So first of all, the integral that we are given is a 0 to 1, 0 to 1, x square to 2 minus x, xy dy dx, because limits are in terms of x. So this 0 to 1 as it is, integral 0 to 1 as it is, we are integrating with y. So x is like a constant. Integral of y is a y square by 2. Limits are x square to 2 minus x. That is a dx. Next step, we go to the replacement of the upper limit minus lower limit. We replace y by this 2 minus x. So 1 by 2 is a constant that can be kept outside also. Okay. Or I will write it here, 2 minus x bracket square upon 2. This upper limit minus, now we'll replace y by x square. X square raised to 2. So it is x raised to 4 by 2. Is it? Dx. So this 1 by 2 is a constant throughout, come outside common. So this is a integral 0 to 1 x as it is. Now I'm going to square this bracket, 2 minus x bracket square. So 2 square is 4, 4 minus 4x plus x square. This is the square of the first bracket minus of x raised to 4 as it is dx. Now to integrate this, still this x is outside, so I will take x inside again, inside the bracket. It is a 4x minus 4x square plus x cube minus x5 and dx. Now two steps only left. Just we have to integrate this with respect to x and put upper limit and the lower limit. A simple integration, the same formula. So I'll write this side. So this 1 by 2 is a constant as it is. Integration of 4x is a 4x square by 2, 4x square by 2 minus 4x cube by 3, then x4 by 4, integral of x cube, and lastly x5, that is x6 by 6, and the limits 0 to 1. Just replace upper limit, because for lower limit everything is a 0. So it is a 4 by 2 minus 4 by 3 plus 1 by 4 minus 1 by 6. That's one. So this is the number that we have to simplify. Now there are two ways. One of the way, you can go to the LCM and write the answer in the fraction, or use a calculator and write the answer in the decimal. Both way you can write the answer, either the fraction or the decimal. So if you want, see here the LCM is a 12. So to maintain that LCM, we should multiply, see here is a 2, so to make it is a 12, we multiply by 6, 6 4s are 24. So to get 12 here, we multiply by 4, so minus 16. To get 12 here, we multiply by 3, so plus 3. And to get 12, we minus 2. So everywhere is now the denominator is a 12, so that is LCM. So after simplification, now you see 24 minus 16 is a 8. 8 plus 3, 11. 11 minus 2 is a 9. 9 by 24, is it correct? 9 by 24, but yes, it can be simplified. 3 3s are 9, 3 by 8, 3 by 8. So if you're not happy with the fraction, yes, you can write the answer as 0.375 also, 0.375. So if you use this number on calculator only, so calculator gives you the number 0.375, so directly you can write this. If you're not good in the LCM. Okay, so choice is your answer can be a 3 by 8 or it can be a 0.375. So both way you can write it. Okay, so the answer can be a 3 by 8 or 0.375. 3 by 8 or 0.375. Yes, that about your example 4. So I hope you are able to understand now how to evaluate the double integral. Example 5. Now this is another way of giving the double integral. In this way, actually the order is given directly. So you are given this inner integral completely inside, that is with respect to y, and then the outer integral with x there. So we our aim is to evaluate this 0 to x e raised to y by x dy first. Okay. The most important thing again, you will observe as we are integrating this with respect to y, x is like a constant. So x is like a constant. So in which formula this integral will fit? So which of the formula is there? So obviously we e raised to y dy. So e raised to ax dx. So this is the form where we have to fit the formula now. So what we can do it, so for simplicity, for getting that integration, if you are able to integrate it directly, like e raised to y by x upon 1 by x, it's okay. You can do that directly. If not, see, this x is a constant. As we integrate with y, x is a constant, so 1 by x is also constant. So let I assume that 1 by x is a constant, so I'll take 1 by x as a. So this is actually a side work, we should do it. So I will say this is the formula we are going to use it, we are going to fit it that. So the side work that we are going to do it here as integral e raised to y by x dy with respect to y. So this integral we are going to do in a side work. So let 1 by x, let 1 by x is a. So the integral become e raised to a y dy. And now you see the formula is fitted now. This is the formula number 1 we require. So it is a e raised to ay upon a, that's the integral, where we resubstitute the value of a. The value of a is a 1 by x. So e raised to y by x upon 1 by x. So indirectly the integral is x into e raised to y by x. X into e raised to y by x. So if you are able to write it directly, that's good. Now to evaluate this integral, to evaluate our integral I, which is 0 to 1, this integral we already done in the side work here. This is the side work. This is the side work we done. So I will use that value directly. The value is x into e raised to y by x. X into e raised to y by x, limits are 0 to x, and the dx is as it is. This dx is as it is. So here this 0 to 1, we are going to replace upper limit. You will observe x into e raised to x upon x. X upon x is 1, is it? E raised to x upon x is 1 minus x into, now we replace y by 0, so e raised to 0, that is 1. So this one we left. And now it is very simple. How to integrate the first term, x into e? Just the formula number 2. Remember, e is a constant, e is a 2.71. E raised to x is a function. So if x into e raised to x is there, we use a by part. But here just x into e is there. So simple integration. So integral of x is x square by 2 into e minus integral of x again x square by 2. Limits 0 to 1. When we put upper limit, it's a 1 by 2 e minus 1 by 2. Lower limit, it is a 0. So the answer is 1 by 2 e minus 1. That's the end of a question. So simple, so simple. Only the side work is important. Treating the other variable is a constant is very important. When we integrate with y, remember x is like a constant, 1 by x is also constant, and we can easily fit in the formula of e raised to ax. That's one. So already we seen the answer is 1 by 2 e minus 1. That about the example 5. Okay, next question, example 6. It is exactly similar to the previous, same integrand, similar order. So obviously we have to treat that 1 by x like a constant. So exactly same way like in the previous example, our first integral will go like this, 0 to 2 as it is. We are integrated with y. So the integration is x e raised to y by x, just like a previous question. 0 to x square and dx, that only we left. So here we have to put upper limit to the y. So x e raised to, now x square upon x e raised to x minus, now we replace y by 0, so it is only x dx. So what is the extra thing that you will observe? The first integral is not simple. It is the formula 4 that you have to use, integration by part, that is u into v. U into v. By integrating by part, by integration by part, we can do that integration. First function x into integral of second minus integral of derivative of first, derivative of x is 1, integral of. So this is where we can do the integral where the limits are 0 to 2. This minus x integral is x square by 2, where the limits are 0 to 2. So this integral is still not completed. X e raised to x, integral of e raised to x is e raised to x only, 0 to 2. And here 4 square upon 2 is a 2. So minus 2 is the value of this term. Here we put upper limit now, 2 e raised to 2 minus e raised to 2. This is for upper limit. For lower limit, when we replace x by 0, this 0 into this is 0, but e raised to 0 is 1. Lower limit have the minus sign. Lower limit minus sign and this minus sign, that minus minus become plus, e raised to 0 is 1, minus 2. So that's one. So the final answer is now 2e square minus e square is e square, and plus 1 minus 2 is a minus 1. So e square minus 1 is the value of this double integral. E square minus 1. Okay. The value of double integral is e square minus 1. That about the example 6. Okay. What is the most important thing? All that 11 prerequisite formulas that I'm showing on the screen, you should be good enough in that, and you should be able to correlate. You should be able to correlate the integrand in one of that formula. So you should click which formula you are going to use it that. So see the 11 formulas are on the screen, and see the integrand and think about a formula, which formula will be fitted, which formula will be fitted for this integral. So first thing on the limits are 0 in terms of x. So we should integrate with y. So order is a dy dx now. So if we integrate with y, this x is a constant. If x is a constant, 1 plus x square is also a constant. So constant into y square, constant plus y square. So you'll observe the formula number 7 is in that form. So this is constant into y square. So here formula is in variable x, we want in y there. So what you can do it, we are going to use the formula 7 only. So formula 7. So you can assume as we integrate with y. So remember x is a constant. So 1 plus x square is also constant. You can take 1 plus x square as a square. So we're assuming 1 plus x square as a constant till we integrate for y only. After that, a is not a constant, a is a function of x there. So the integral, what will be the double integral become now? 0 to 1. I can write integral 0 to a, and this is a dy upon a square plus y square and dx. See what I done, 1 plus x square is a square, so root of 1 plus x square is a. So 0 to 1 as it is. Now integral of 1 upon a square plus y square by the formula number 7, it is 1 by a tan inverse of y by a. That's the integral, limits 0 to a dx as it is. So this 0 to 1 as it is, we put the limit now. So 1 by a, when we put the upper limit, tan inverse 1 we require. So a by a is 1. Tan inverse 1 is a pi by 4, is that? And the lower limit, when we replace y by 0, tan inverse 0 is a 0. Tan inverse 0 is a 0. Is that clear? So two values we use. When we put y by a, tan inverse 1 is a pi by 4. and tan inverse 0 is 0. You can use these, you can check these values on a calculator also. Tan inverse 1 calculator give you 45 degree, means pi by 4, and tan inverse 0 is a 0 there. And dx we left. Now don't think a is a constant. A is a function of x, so you cannot take it outside. So this pi by 4 is only the outside. Pi by 4 is only the outside. Integration 0 to 1. The value of a, I'm going to replace it here. And the value of a is root of 1 plus x square. Now you correlate this integrand with one of the integral here. Which formula will fit? Which formula will fit? See the formula 1 upon root of 1 plus x square. Yes, the formula 8. Is that? This 8th formula will be useful here to integrate this. So this pi by 4 as it is, integral is log of x plus root of x square plus 1 by the formula number 8. Limits 0 to 1. Only the last step is left. We have to just put upper limit and the lower limit. Okay, we have to just put upper limit and the lower limit. So pi by 4 as it is, this is a log of, when we replace x by 1, it is a log of 1 plus square root of 1 plus 1, that is 1 plus root 2. That is upper limit, minus lower limit. When we replace x by 0, you get log of 0 plus root of 1, that is log of 1. Remember, log 1 is a 0, log 1 0, so this is only the answer. Pi by 4 log of 1 plus root 2. Pi by 4 log of 1 plus root 2 is the answer. That's one. Because when what happened here, what happened when you replace this lower limit, you get here uh, log of 1. How log of 1? Because when x is a 0, this is 0, this is a 0 plus 1, so root 1 is 1, log of 1, and this log 1 is a 0, this log 1 is a 0, hence the final answer is this one, pi by 4 log of 1 plus root 2. That way. That's the 7th question. Come to the next. Okay, second last example. So here is the double integral and limits are in terms of y, so we should integrate with x first. So to integrate it with x first, so we get here the integral 0 to 1, 0 to y, 0 to y, x e raised to minus x square dx and then dy. This integral we have to do it first now because the limits are in terms of y. So which method now? Here is a common silly mistake that many students think. They think about by parts. That's formula 4, but it is not correct. By parts will be used provided x into e raised to minus x is there. Only e raised to minus x should be there. Okay. So the method that we should use it here is a substitution method. That is a formula 6. Whenever fx and its derivative is present. So what is fx? Fx is x square and its derivative is x dx. Both are present, then it is a substitution method. So let I show you how we use substitution method here. So this is the substitution method only. So x square is t, x dx is we say here our aim is to integrate this x e raised to minus x square dx. So this is the side work again. So let x square is t, let x square is equal to t. So you'll observe 2x dx is a dt. So if x square is t, 2x dx is dt. So this integral will be become, so this integral I will become integral x dx is dt. So e raised to minus t into dt by 2. That's one. So 1 by 2 is constant outside. Integral of e raised to minus t is a e raised to minus t upon minus 1. Resubstitute the value of t, minus 1 by 2 e raised to minus x square. So whatever we done up to here, this is just a side work. Okay, so this is the side work that we require for the integration of this one, and that integral we done it there, so we use it here. So integral of x e raised to minus x square is a minus 1 by 2 e raised to minus x square with the limit 0 to y. Remember here is xy is there, so y dy, I missed y here outside, so I written that y dy, so into y dy there. So very simple thing left now. Just put up the upper limit minus lower limit. When we put upper limit, you get minus 1 by 2 e raised to minus y square. That is upper limit. When we replace x by 0, anything raised to 0 is 1. So but lower limit have a minus sign. That minus minus plus 1 by 2 y dy. Now throughout this 1 by 2 is a constant outside the integral. We left with integral 0 to 1. So y into 1 is y, and here is minus y e raised to minus y square. Now, very interesting thing here. So if you observe, this is the integral of y e raised to minus, and initially is x e raised to minus x square. So exactly same way we get integral. The integral of y e raised to minus y square is minus 1 by 2 e raised to minus y square. So this is the way we can write it. So 1 by 2 as it is, the integral of first y is y square by 2, and that minus 1 by 2 minus minus is plus 1 by 2 e raised to minus y square is integral by the same side work. Okay, exactly same, only x is replaced by y, and limits are 0 to 1. So the last step is left. We replace the limit here. So 1 by 2 is a constant as it is. When we replace y by 1, it is a 1 by 2 times plus 1 by 2 times, okay, 1 by e raised to minus 1, e raised to minus 1. So this is we replace y by 1. Now we replace y by 0. When we replace y by 0, this is a 0, but anything raised to 0 is 1. Lower limit have the minus sign, so that become minus 1 by 2. So this plus 1 by 2 minus 1 by 2 gets cancelled. The answer is 1 by 2 into 1 by 2 is 1 by 4. 1 by 4 e raised to minus 1. This is the answer, or we can write the answer as 1 upon 4e. 1 upon 4e is the answer, and that is the end of the question. That is the end of this question. So the answer is 1 upon 4e. You can see whatever the question that we done. And after this, yes, here we have the last example. The last example is here, which is actually solved example from the BS Grewal. So evaluate this solved example 7.1. Evaluate the integral 0 to 5, 0 to x square, x into x square plus y square dx dy. See, the limits are in terms of x. We should integrate with y first, and obviously the formula number 2 only we require here. Formula number 2 only we require. So to first we'll integrate this with respect to y. So take x inside, and when you integrate x cube with y, the integral will be x cube y. So that is the important thing that you should remember. Don't write only x cube there, or don't write only x square. Let us show you the solution only. The solution is here. So first the integration with y is done. So integral of x square is written as x square y. Integral of y square is a y cube by 3. The limits are 0 to x square. So when we put upper limit that we are replacing y by, we're replacing y by x square. So when we replace y by x square, it is x raised to 4. Here is a correction. It is x raised to 6 by 3. X raised to 6 by 3. And after that, take x inside and integrate it. Your answer will, you can keep the answer like this, or you can write the answer in the decimal. Either write this one. So this is not compulsory to write. You can write the answer as 5 raised to 6 by 6 plus 5 raised to 8 by 24. Okay, so that about your type 1 example. You will understood what are the important things here. List of that 11 prerequisite formula. When you observe the integrand, decide which formula you are going to use it, and check the limit first. Inner limits are in terms of x. It indicate you should integrate with y first. Integrate with y first. That is the important thing where you should focus. So that about the main important examples of the type 1. Okay, so thank you so much. In the next session we can start the type 2 examples there. Okay, thank you.